morning, dear students. In these sessions, we shall see thermal physics. In the previous class itself, I said what is physics. Physics is a subject which deals the natural phenomena that takes place in the universe. Particularly, we are going to see in these sessions about the thermal physics. Myself, Dr. N.M. Ganesan, Associate Professor, Department of Physics, Erode Sengundar Engineering College. In these sessions, the topic that we are going to cover are basic definitions in thermal physics, different modes of heat transfer, need of heat exchanger, and principles of micro oven. Before to see those basic definitions, we shall see what is a thermal energy and the common unit used in it. The thermal energy refers to the energy contained within the system that is responsible for its temperature. That means if we feel to touch a body very hot means it will hold more amount of heat energy in it. So the temperatures and heat energy is directly proportional to each other. If temperatures more means it will hold more heat energy in it. The SI unit used to measure the heat is joule. This may be defined as amount of heat energy required to raise the temperatures of whole substance through 1 degree Celsius above the room temperature. Usually we know the room temperature is around 28 degrees Celsius. See, I am using these two tanks to explain the flow of water from higher pressure to lower pressure. We know very well that liquid flows from high pressure to lower pressure. That means the liquid flows from tank 1 which is a higher level to lower level. The amount of water flowing through the pipe and amount of water collected in the bottom tank depends upon the pressure difference between the two tanks. Second one, the length of the tubes. If length is small, more amount of liquid will cross from a tank which is at a higher level to lower level. And the third one is area of cross section of the tube. If the cross section area of the tube is more amount of will flow from higher level tank to lower level tank. So we can conclude that the amount of water collected in the lower level tank depends upon the first one, pressure difference, second one, area of cross sections of the tube, and third one is time. If more time is allowed, more amount of water will be collected in the tank which is at a lower level. And the last one is length of the tube also decide the amount of water collected in the lower level tank. If the length of the tube is less, more amount of water will be collected. I am using this diagram to explain the thermal conductivity, that is the amount of heat flow from hot end to cold end can be explained easily with the help of water flow from higher pressure to lower pressure. We shall see the thermal conductivity now. The thermal conductivity may be defined as the amount of heat energy transferred through unit area in unit time under unit temperatures gradient. Unit area means the area may be taken as 1 square meter. Unit temperature gradient means the variations of temperature with respect to length. If it is 1, we can say the temperature gradient is unit. These statement, that is the amount of heat energy transferred through unit area in unit time under unit temperature gradient, may be represented by the equation Q directly proportional to area of cross sections of the rod and directly proportional to time and directly proportional to temperature difference, whereas inversely proportional to length of the rod. In the second equation, the proportionality is removed by two factors. One is equal sign and another one is a constant K called thermal conductivity. Our aim is to find thermal conductivity K, whereas K is equal to the second equation is replaced or rewritten as Q by AT. This T represents the time, whereas T1 and T2 represent the temperature difference, where L is the length of the rod. The unit for thermal conductivity is watt per meter per Kelvin. The specific heat means the name itself implies that specific, that means the amount of heat energy required to raise the temperatures of 1 kilogram substance through 1 degree Celsius above the room temperatures. For example, if you take 1 kg of silver and 1 kg of copper and 1 kg of stainless steel, the amount of heat energy required to raise its temperature from 28 to 29 degree will not be same. Here 28 degree is considered as room temperatures. We can precisely say how much amount of heat energy required to raise 1 kilogram of substance, 1 kilogram of given substance to raise 1 degree above the room temperature. That is called specific heat capacity. Mathematically, it can be explained or written by the formula specific heat capacity C equal to del E by mass into del theta. Del E is a change in temperature. Del E is a change in thermal energy and del theta is a change in temperature, where M is the mass of the substance that we taken. This is a simple diagram. In this simple diagram, we can explain all the three modes of heat transfer. This is usually used in our house to prepare tea or coffee at home. In the case of conduction, heat is transferred from one place to another place, that is at the bottom of the kettle to our handle, without the actual movement of atom or molecules of the kettles. The kettle may be made of either stainless steel or aluminium. The atom of stainless steel or aluminium is not transferred from one place to another place to reach the heat to our hand. Sharply, we can say that heat is transferred from one place to another place without the actual movement of heat. This belongs to conduction mode. Whereas in the case of convection mode, heat transferred from one place to another place is due to the actual movement of atoms or molecules. Usually this could be takes place in liquid or gas. The last one is radiation. In this method, there is no medium to transfer heat from one place to another place. This is what happening in our universe. That is, heat is transferred from sun to earth without any material medium. The slide shows the different type of heat exchanger. The heat exchangers are very useful nowadays. If you are not use the heat exchanger, we cannot reduce a huge amount of heat developed in the engine parts. To reduce the excess heat in the engines, we allow some liquid to pass through the engine parts. This liquid receives heat energy from the machinery parts, and it is allowed to pass through the exchanger tube. Usually the exchanger tube is made up of very good thermal conductivity, while the liquid which is carrying more heat is allowed to pass through the exchanger tube. Above and below the exchanger tube there is another liquid flowing either in the same direction or in the opposite direction. If the second liquid, which is at usually at a room temperature, is flowing with the liquid in the exchanger tube or in same direction, then that flow is called parallel flow method. If not, the liquid flowing in the heat exchanger tube as well as the liquid that we sent through the exchanger to reduce the heat of the hot liquid are in opposite direction, then that arrangement is called counterflow method. Both the methods are doing the same work, but the rate of cooling is differ. Another one method is there, that is called cross flow method. In this method also heat is exchanged from hot liquid to cold liquid without mingle with each other. If you do not follow any of these methods, the engine parts will be easily worn out and lifetime will be a question mark. It will not be economic to our family as well as our nation. So heat exchanger is very essential. The electromagnetic spectrum is shown in the slide. This slides gives information that as frequency increases, wavelength decreases. In this spectrum, we are going to consider only the microwave regions, whose frequencies are around 10 power 8, whereas wavelength is 10 power minus 2 meter. These microwaves are produced with the help of a vibrator inside the micro oven. While these microwaves are passing through the grains of the foodstuffs, they vibrate vigorously. During that vibration, heat is evaluated in the grains of the foodstuffs. So the foodstuffs boiled uniformly, even within the 2 mm thickness of the foodstuffs. The basic diagram usually used to explain the micro oven is shown in the next slides. See, this is a diagram for micro oven. The foodstuffs to be boiled is kept inside the micro oven using a vibrator. Microwaves are produced. As the microwaves passes through the foodstuffs, the grains of the foodstuffs start to vibrate and produce heat energy. That energy is sufficient to boil the foodstuffs evenly, even after the 2 mm thickness of the foodstuffs. Thank you for your patient listening, and you can interact me through the YouTube link at any time. Thank you.